Right, let's have a look here. Okay, two airplanes are flying in the air at the same height. Airplane A is flying east at 250 miles an hour and B is north at 300. If they're both heading to the same airport, located 30 miles east and 40 miles north, at what rate is the distance between the airplanes changing? Okay, so 7 L squared equals 30 minus 250t. Yeah, it's going to get there really quick. 30 miles, but it's traveling at 250 miles an hour. It'll just take a few minutes. 30 minus 250t squared plus 40 minus 300t squared. So that's 2 L dot. This is the t derivative. That will equal 2 times 30 minus 250t times minus 250 plus 2 times 40 minus 300t times minus 300. So the cancel out the 2's, and I can get the L dot is 30 minus 250t. Is the t 0? I feel like it might be, because it says at what rate is the distance between the airplane changing? Or do we keep the answer with t in it? So that would be, yeah, minus 250 times 30 minus 250t plus minus 300 times 40 minus 300t all over L, which is root 30 minus 250t squared plus 40 minus 300t squared. Let's have a look. This is 7. Oh no, okay, so they do want it, I guess, at this moment. So at t is 0, let's take out the old calculator. Minus 250 times 30 minus 300 times 40 over root 30 minus nothing. 30 squared plus 40 squared. Minus 390. Yeah. At what rate is the distance between the airplane changing? Yeah, and it's like got a minus, so it's 390 miles per hour, but minus because the distance is decreasing. At what rate is the distance between the airplanes changing? Yeah, I feel like the negative should be there because it matters because they're getting closer. So maybe I'll open a ticket about that. Okay, you and a friend are riding your bikes to a restaurant that you think is east. Your friend thinks the restaurant is north. You both leave from the same point, which you riding 16 miles per hour east and your friend 12 miles per hour north. After you travel 4 miles, at what rate is the distance between you changing? Same deal again. You can go straight into the formula here. L dot equals root Um, 16t squared plus 12t squared, um, and the derivative would be 16t times 16 plus 12t. Oh, yeah, um, times 12. So we want the time for when it reaches 4, and this is 16t and 12t. So what would the t need to be here? Let's have a look. Okay. Just 1/25 of an hour. Okay. Okay. Okay, so subbing that in, we'll get 20 miles per hour. Yeah, that seems bigger than I thought. Would it? No, guess not. Okay, 9. Two buses are driving along parallel freeways that are 5 miles apart, one heading east and the other heading west. Assume that each bus drives at a constant 55. Find the rate at which the distance between the buses is changing when they're 13 miles apart, heading towards each other. Okay, so there's one bus here. And these are 5 miles apart, and that's heading 55, and that's heading 55, and I assume the 13 is a diagonal distance or not. Find the rate at which the distance between the buses is changing when they're 13 miles apart. Is the 13 going to be this? Or do they mean this? Because just kind of how you would use English. If I said the buses were 13 miles apart, kind of mean like the road length, not the diagonal. Fortunately, it's an odd question, so I can know if I'm right by checking the answer at the back. Okay, so um, and what was the 5? Oh, that was this here. Okay, so the distance squared. Hmm. 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 Do we know that? Okay, we know they're 13 apart. What will I do with the 13? Could be 13 and 5. That would make it 12. Could be that. So this distance here is 12. I don't know why my pen got so thick. Oh, here we go. 12 minus 55. Actually, I think I prefer the darker one. 12 minus 55 t squared plus, oh, now actually, because the other one is moving in as well, that's going to change things a little bit. L squared would be this length here, and that length would be 12 minus 55t minus 55t squared plus 5 squared. So 2L dot will be 2 times 12 minus 110t times minus 110. And when the t is 0, that will be minus 24 times 110 over L, which is 12. So that's minus 220 miles per hour. Now that's going with the 13 being the diagonal. Let's find out. Maybe the diagonal wasn't 13 then. So if it wasn't 13, then what would change is that if the diagonal wasn't 13, if it was the horizontal, that's 13. So that 12 would become a 13. And that would become 13. And that would become 26. And that would be 13. Oh, it's still the same. No, that can't be right. What have I done wrong here? L squared is the distance, which is definitely, I'm saying 12 minus 55t minus 55t squared plus 5 squared minus 55 minus 110. And then the L is 12. 9. 101.5. My answer is like it's missing a 2. Interesting. I'm doing something wrong here. Two buses are driving along parallel freeways that are 5 miles apart. Okay. One heading east and the other heading west. Okay. Assume that each are driving at 55. Okay. Find the rate at which the distance between the buses is changing when they're 13 miles apart. Taking the 13 as a diagonal. So 13, 5, 12. And that distance, L squared, definitely has to stay constant, 5 squared. So it's 12 minus the distance each of the cars have traveled, which is 55t. And I bring down the power, reduce the power by 1, and multiply by the inside derivative. And then, oops, that should have said 13. There's my mistake. So 2, okay. 2640 over 13, but okay. Oh yeah, why what? Oh, Stephen, that should that 2 is gone. It's cancelled. It's cancelled. So it's actually a 12. Oh dear. Okay. Now we're right. That's correct. That's correct. I hope that that one's correct. It's a nice answer. Of course, it's not a guarantee it's the right answer, but we hope it's right. Okay. Yeah, that's a good point to leave it there. Yeah. Okay, thanks for watching.